See, this is, believe it or not, this is
take this thing around. It's not going to circulate very well.
In the bag.
Great. Thank you very much. I really appreciate it.
Could
anyone have any installation issues? You need assistance with?
Lisa, could you test the audio?
Yes.
Just you have an Hangout invite, and you can just go to the YouTube link also and see if audio is coming through. It's far enough. You're far enough back that you won't interfere with the sound, probably. Either. The attendance for this is making me wonder if I should like the high sign up rating. Making me wonder if I should like just go find the weeks that are not during classes and just stop the workshops then. It's all right. Are we okay on most of the install problems? Where'd Chris go? There he is. Could those of you that have intractable install problems just put a red sticky on the back of your laptop like this so that I can see it? Not having tried to run RStudio counts as an intractable install problem. That's kind of a joke, but not really. Okay. And okay, I should be coming through the room speakers now, right? That's a little loud. How about now? Okay, I think that's better. I might not need it. Hey, Chris, can you hear me in the back row? Yeah, so I should use this. Okay.
Do you want me to create a YouTube? Do you want me to create a YouTube?
So the YouTube video should be linked off of the Div training page. And you should have an invite to Google Hangout in your email.
Yes.
And the sound's good?
Working, yeah.
Cool. All right. Okay, I think in the interest of expediency, I'm going to get started. There will be a couple minutes of that's loud for me up here. Sorry to turn down the volume. How is this lower? No, that's not lower. I'm under the speaker. It's true, but so is everybody else. All right. Okay. So everybody, welcome. This is the intro R workshop. If you're not here to experience the wonders of R and RStudio and RMarkdown, then the cookies are in the back, and you should feel free to partake. I have a little welcome spiel that I go through. I'm Titus Brown. I'm a professor over here in the School of Veterinary Medicine. You're in actually the Valley Hall Vet Med Training Facility. I do a lot of work on genomics and bioinformatics. So I end up doing a lot of data analysis and data manipulation. And so for that and other reasons, I run a workshop series that's intended to teach more of the, expose people to the sort of daily details of data analysis more than the theory and background of statistics or genomics and so on and so forth. Mostly in the interests of showing you what it looks like, getting you used to some of the tools, getting you into some of the tools, and then providing you with an opportunity and an entree to come talk to other people on campus that do this kind of thing. And I'll tell you a little bit about that in a second. But first, we have a number of TAs and helpers around the room. And there's enough that I'm not going to ask them to introduce themselves, except to say that I'll point them out. So Daniel Standage is a postdoc in my lab. Lisa Cohen in the back is a grad student in the lab. Karen Word is a postdoc in the lab. Chris Ham in the back is a postdoc in the lab and also has been a postdoc here at Davis and some other labs, at least one other lab. Luis over there is a graduate student in the lab. And am I missing anybody? Okay, so I can't imagine they came because they liked hearing me speak, but they're here in case you guys run into problems. So, and I'll tell you how they'll know that in a second. All right. All right, so this is part of the training workshop series. I ran, I think, more like 8 workshops in the fall. They're all introductory level. And the goal of the point of having them be introductory is that turns out there's a lot of people that are interested in data analysis and data analysis tools, but not a lot of people that have in-depth experience with that. And so this is sort of to get people into it and then introduce them to what else is going on campus without having any sort of bar. So I call these sort of zero entry workshops. I have kids. Zero entry pools are the ones where there's when the toddler starts running, they don't fall off a step, right? They just slowly enter the water and hopefully give you time to rescue them. So these are intended to be zero entry in general with no prior skills required. Really what they are is a foil for other things, including the office hours that we've been running on Wednesday for the last quarter and the quarter before that. They're over for this year, but starting in the new year, I think after January 9th, so probably January 11th. We'll be doing office hours every Wednesday, 3 to 5:30 or so over in the my building, which is the Center for Companion Animal Health. We'll announce this to the DIP training mailing list. I'll send you a link to that after the workshop. The point of these office hours is that if you are working on data analysis and you run into any problems, or you just want to hang out with other people that are working on data analysis, you can come. You don't have to have a problem. You don't have to have a problem. You don't have to have a solvable problem. Obviously, you want to know that in advance. Just a friendly group of people, some coffee, sometimes cookies, and you can just hang out. We have a number of people who are experts on genomics and Python and R, and we're happy to help. We're all happy to help. New, we have a Slack channel. For those of you that use Slack, there's a UC Davis Slack, ucdavis.slack.com. The channel is called Mad Dibs. The reason for that is that we call our office hours Meet and Analyze Data, or MAD. So let's see what else. So I had one more workshop this year, Jupyter Notebook for Exploring Your Data. We have enough people signed up already that I'm going to go forward with it. It's next week. I don't know how many people will actually be around, but I'll be here and I'll be talking about it. And so this is going to be sort of a counterpart for people who are interested in Python and some of the other tool chains that are used in reproducible research and data analysis. Today's going to be about RStudio and RMarkdown. This workshop, along with all my other workshops, operates under the Software Carpentry Code of Conduct. You can go read that, but basically don't harass people and be nice. The worst that will happen is I'll ask you to leave if you're being disruptive, basically. We've actually have never had any problems, but I don't want to start having any problems. So. Okay. I am recording this. It will go on the website that you used to sign up. It's a live stream YouTube video. You can go check out now if you want to hear me in like echo format. The recording is by default public. Generally, it's only got my face and my screen on it. In fact, I don't think I've screen shared, so I'll do that as soon as I exit PowerPoint. And basically, the goal is that if you have a question about something that happened or you want to go see exactly what I did, the video will be there. It's not going to be professional quality. It's just going to be a recording of this workshop. One other point is that like everything else, like the workshop materials, the video will be essentially permanent. So as long as YouTube is around, I expect to leave the video up. So. And feel free to forward the materials in the video to anybody who you think might be interested. All right. So you should both have two sticky. You should all have two stickies. One sticky will be, I think we've mostly gone with red or purple or whatever this color is, and yellow. Did we go with yellow or did we go with, okay, yellow? We're going to call red I need help, and yellow is I'm all good. This is a way that I can use to, I can gauge the temperature of the room in terms of how fast I'm going, whether or not people are running into technical problems. The proper sticky placement is to put a sticky on the back of your laptop, not like this, because if you put it like this, then people behind you can't see it. You have to put it like this so that someone standing in the back, like say Chris, can see the red and come. This is far superior to raising your hand and holding it over your head until someone comes and finds it. And then when we're doing certain things, I'll say, put a yellow sticky up when you're done and you've succeeded. Put a red sticky up if you're done and you haven't succeeded. And take all the stickies down and you're still working on things. Better than clickers, basically. All right. So what else do I want to say? So this is my training workshop series. It's more or less sponsored by the School of Ed through my salary. But there's actually a lot of other stuff that goes on campus. There's the Bioinformatics Core offers a genomics training series about genomics and bioinformatics. There's HPC training that's been happening once a month, which is sort of presentations and discussions. And then the Davis R Users Group is this wonderful, awesome resource group of friendly, mostly graduate students, I believe, on campus. You get together once a week to talk about R and all things R. They're not biology focused, but there's a heavy biology representation. They're just incredibly welcoming and friendly. They will be sending out an email soon about meeting times for next quarter. You should sign up for that list if you're interested in hearing about it. I'll probably announce it also to the training list when they send out that email. The other thing is that I just started doing an introductory grad course on R in next quarter, which I believe is the winter quarter here in California. It will be announced soon. Ryan, I hope we get it, yes, Brian Peak will be teaching it. It's going to have room for about 25 grad students. It's intended for intro grad students. But it will be a full-length, a full quarter class on R.
Is it a statistics course?
It's an R course. So it's about how to use R, assuming that probably, I mean, I don't know, but the way he pitched it is that trying to learn both R and statistics at the same time is hard. So why not teach R separately from statistics? Because a lot of people need to use R without necessarily using a lot of heavy statistics. So I think that's what it's going to be.
There's another course.
Cool.
For it's ECI 289.
ECI 289?
Yeah, Deb Niemeyer.
Oh, Deb Niemeyer is Niemeyer or Niemeyer? I always forget. Sorry. Anyway, okay. And that's about R.
Data analysis in the built environment and introduction to R.
Cool. Great. Thanks. All right. Any other comments, questions? All right. On that note, I have one more warning for you. So this course is about R, and I don't actually know R particularly well. Why are you up there teaching it? A couple of reasons. One is that I'm actually paid to do this kind of training, and it seems rough to like ask my grad students and postdocs to do the training when they're not paid to do the training. They still show up, which is awfully nice. But, the other is that actually often the best person to teach something is somebody who sort of only has the most recent and somewhat shaky grasp on it. So part of the reason I'm mentioning this is that I will be asking Chris Ham in the back, who's actually my local R expert, questions from time to time. Or he will be volunteering answers whether or not I ask questions. I think it's probably a more accurate way to put it. And in part that's because I don't necessarily know all the details. And in part that's because nobody knows all the details. Everybody I know has to use Google for things all the time. I'll probably give you some demonstrations of that during the workshop. The other warning is that you can't learn R in a week, much less a day, much less half a day. So what this workshop's really about is showing you talking you through RStudio and RMarkdown, which is an incredibly valuable tool for reproducible research. I want to show you some features, give you an opportunity to ask questions about concerns or issues that you have, and basically provide you with this couple entry points into the our pantheon of online tutorials and help documents and so on and so forth. So I think the most important thing is you walk out of here knowing whether or not R is going to be, having a better idea whether R is going to be useful for you in the near term. And then from there you can go on to other resources, including our office hours or the DataStar users group and others, as you embark upon your journey or extend your journey of learning R. Is there anything else I should mention? Good. All right. Okay. So without further ado, let's get started. So first, let me start screen recording. Here. All right, so where we're going to be starting is links that are based off of the specific workshop page for today, which is the RStudio and RMarkdown for exploring your data page. So on this page, there are 3 links that are important. The video recording link is a link to the live YouTube. The materials link we'll be getting into more, and then the Etherpad is where we'll be posting code and so on for copying and pasting. So what I would recommend doing is connecting to the Etherpad and leaving it open in a side window, and then being able to go back to it quickly. If you go look at the Etherpad page, Etherpad is essentially a live sort of chat, but it's a live collaborative document. Think Google Docs, but with colors. I've provided direct links into the various lessons and so on that we'll be going through, including the link that you could find nowhere else, which is a link to this RMarkdown file that we'll be using around noon to demonstrate some of the basic capabilities of RMarkdown. As you can see, there's a chat interface. Since this is not a remote workshop, we're all present in the room. I suggest just flagging me down by raising your hand or putting a sticky up or getting TAs rather than posting things here. But if there's something that you want to put here for later to remind yourself, that's totally fine. And then just say, hey, I asked a question in the chat. I no longer remember what it is. You go look. And then do that. Okay, so Etherpad is something you should maybe keep up, but the primary thing is the materials link here. And the materials link, this is actually a link to a much longer workshop that I believe was originally offered here last summer by Mike Levy. There's a week-long R workshop. If you've attended that, I'm not going to say much new. So I'm doing half a day what he did in about 3 to 5 days. But all the links are here. And I think the most important thing about this set of materials is just to remind everybody, everything I'm going to say plus a lot more is here, and it's presented nicely, and it's copy-pastable. And so anytime you're wondering what I said, why I said something, in a week, in a month, come back to this page, and these materials should be here, and they'll be kept updated because they're part of the data and software carpentry collection materials. Good. All right. So one of the other workshops that I offered in the fall was a workshop on something called OpenRefine, which is a spreadsheet data management and data cleaning with OpenRefine. And OpenRefine is a great bridge between Excel, where you're working with maybe a couple dozen or 100 rows of data, situations where you're working with maybe thousands or tens of thousands of rows of data in a spreadsheet, and then R, where you would be able to do things in batch mode to all that data. And OpenRefine is a fantastic tool that I highly recommend you check out if you end up working with a lot of messy spreadsheets. I'm not going to go into it right now, but the output of OpenRefine is going to be a data cleaned spreadsheet. You have your taxonomy, you have your counts, you have whatever it is you're doing with your spreadsheet in a much nicer form after doing some data cleaning with OpenRefine. And now you want to do stuff with it. And this is where R sort of excels. Wow, that was a bad pun. Unintentional, I should say. So the point of R is actually not so much to just work with large amounts of data, it's to work with large amounts of data and to record what you're doing to the data, and keep track of it and be able to share the process and of the data analysis with other people. And so one of the many reasons that I'm so passionate about things like Python and R is that they take your data analysis and they make it reproducible by you and by others. They make it shareable, they make it publishable, and they make it, in theory, once you've gotten over the learning hurdles, more efficient. So the point is, like, you write down everything you're going to do, and you'll, if you haven't seen too much of R before, you'll see exactly what I mean. You write down everything you're going to do, and then you save that in a text file that you can rerun and share with others. It's both sort of, I don't know how to overstate, I don't think it's possible to overstate how important this is when you're working with large scale data analysis. It also has all sorts of other benefits, like, hey, I just did the 5th version of this analysis on a different data set. I did the same analysis on 5 different data sets. I have another 10 data sets coming next month. Maybe I should just write a single script to do my data analysis and just run that script 10 more times. And that is a much saner way to lead your life than to do a custom analysis each time. So we're going to start by just talking briefly through Introduction to R and RStudio. And as I said, all of the links are off of that page. So anytime you get lost, you can flag somebody down, they can help you find the right page. No problem. So again, I'm not going to be able to go in detail through all of this, but what I want to do is just sort of make sure I touch on all of these different issues. So we're going to be using R and RStudio. R is a programming language that's primarily intended for statistics and data analysis and visualization. RStudio is what's called an interactive development environment, or IDE, integrated development environment, sorry, or IDE that lets you execute R commands and also keep track of what you're executing and see the plots at the same time and so on and so forth. It's super cool, it's super nifty, and basically much more awesome than many of the things that exist for many other programming languages. It's free and it's open source, works on all the platforms, and it integrates version control and project management, which we won't be going into too much today. We've talked a little bit about scripting. There's a bunch of reasons here. Why would you write stuff in R? Power, flexibility. You can go back and update things, and I'll show you with plotting how I tend to work. Is I get my basic plot going, and then I modify it and modify it and modify it until it looks the way I want it to look. And then I copy that code for the next plot, and tweak it until the next plot looks like I want it to look. Nobody that I know, excepting maybe Hadley Wickham, who wrote a lot of the packages we're going to use today, writes the perfect figure code right off the bat. Everybody I know does sort of this evolutionary modification process where they get a basic piece of code that doesn't have syntax errors in it, that doesn't look right, and then they modify and modify and modify. Right, traceability, reproducibility, and communication. And at the end, I'll show you this literate programming, knitr, which we use for the RMarkdown phase in terms of communicating both discussion and code and figures around what you're doing to other people. Okay, so let's start. Let's open RStudio. You should all have it installed, please. I might have to adjust my fonts so that people can see what I'm typing. Yeah, that's going to be bad. Can I do it? Let's look at that. All right, so the basic RStudio environment consists of, in this case, a console window on the left here. This is where you can type R commands. So if you just type 5 + 5 here and hit enter, you'll see that it gives you the answer, which is 10. You have global environment, which I'll show you in a second, history, and then this, which was where our plots will show up, as well as our file browsing and so on and so forth. What we're going to do is, let's see, let me just make sure I touch on everything. So the one thing I want to say about the console is that the console is a great place to demo, test R code. The problem is that it's not a great place to go edit stuff. So if I wanted to say 5 + 6 instead of 5 + 5, I would have to do up arrow and then backspace over, and so on and so forth. And that sounds like you're like, why is that a lot of work? It's not a lot of work, but if you have 15 or 20 commands that you executed in a row, so suppose you created a variable x, which had 5 in it, and then you said y is 5 + 10, and z is y is x + 10, and then z is y + 15. At the end of the day, you have z is 30, but of course, that depends on all the execution that you did in advance. So it depends on the value of X and it depends on the value of Y. If you change the value of X, you have to execute all 3 commands again. And in the console window, the way you have to do that is you have to go and edit each of the commands and run. You have to go and edit the first command and then rerun all the next set of commands. So you have to say, okay, well, actually, I wanted to know the value of Z when X is 10, and then I have to go find the Y command. I have to go find the Z command. And that tells me that Z is 35 now, which I think is right. 10 plus 10 plus 10, yeah. So an alternate way to do this is to go up to File and say New File, RScript. And this will then give you a place where you can write all these commands. I'll make it just as boring as before. And this is now something where you can go line by line, and there's a little button up here that says Run the current line or selection. It's a green arrow pointing to the right. You can click on that, and it will advance to the next line, and it will feed all of those commands into the R console and give you the answer down at the bottom. So this is now a record of the commands that you ran, whereas down here you have sort of a more ephemeral record of what you've been doing in your workspace in the R console. So I highly recommend getting used to the idea that what you do is you edit a whole workflow of commands up in the R script window, and then you can save that and reload it and rerun it at later points. Is that an accurate? It's pretty much what you do? Yeah. Right. Okay. There are always shortcuts, so you can execute all of these lines by doing Control or Command Return on a Mac, and I think it's Control Enter on a Windows machine. And basically, there's this comment, it mixes interactivity and presentation. So what can you use R for? How many of you have had some experience, some exposure to R or some exposure to programming? Okay, so probably like 2/3 of the room or more. So I'm gonna skip through this fairly lightly, but I just want to make sure everybody's on base with the idea, right? With the basic idea. So the first use of R is arithmetic, which I've already been doing. So I can say, you know, what's 52 times 24 times 60 times 7 to get the number of minutes in a year. When I run that, I get 524,160, which is accurate within the limit of me specifying that a year has 52 weeks in it, which is of course inaccurate. But anyway, and so you can do all your basic arithmetic in here. And this is actually pretty nice because if you think about calculators, calculator histories are never particularly awesome if they exist at all. So you're always left with, I'm always left, when I'm using a calculator, I'm always left wondering, like, how did I actually get this number? What numbers did I multiply and add and so on and so forth? You sort of have to remember to do things in the right order with the right association. With R, it's all sort of laid out, so once you're used to reading it, R is associative, so R follows the usual rules of association and commutativity. So if you want to know what 60 plus 20 times 5 is, you have to surround the 60 plus 20 in parentheses, otherwise you get a different answer. If you do 60 plus 20 times 5, you will get the 60 plus 20 times 5, which is 160 instead of 400, right? So you just need to sort of keep in mind how to group things with parentheses, so on and so forth. Something that will no doubt happen if you work at the console a lot is if you type an incomplete command. Suppose I'm doing a 5 plus. And I don't know if people in the back can actually see this. I can increase the font size a little bit, but basically, this is maybe a bad example, but here, because I put a plus on the next line, but basically the greater than is when you start an R command, and the 5 plus is the first part of the command, and then R says, well, I'm still waiting for you to finish this command, and so this is a line continuation symbol. And you can either finish the command, so I can say 5 plus 5, because I have a multi-line command, or I can say 5 plus and then hit escape, and R will go back to the entry. If you're working at the R console outside of RStudio, I believe you have to hit Control-C to break out of that, rather than hitting escape. You should always work in RStudio, basically, unless you're working on a remote computer where you don't have access to RStudio. So there's this great comment here. White space is ignored by R, right? So I've been putting spaces in between my numbers and my operators. Basically, if you don't use spaces, you'll end up with very hard to read code. And if you do use spaces, it'll be much easier. Here, they're taking advantage. You're taking advantage of the rules of commutativity. So it's 2 to the power of 2 times 5 plus 3, which is explicitly laid out with parentheses. I generally recommend putting parentheses around virtually everything because many of the most common errors I run into in my own code are from inaccurately putting in this kind of expression. You can also put in comments. So here you can see these comments. Anything after the pound sign is a slave code. Let's see, what else should I talk about? So there's a lot of stuff you can do with R as a basic calculator. So you can run sine and log. So the natural log of 3 is using the function log and gives you the result natural log of 3. Rather than run through all the functions, there's essentially all of the mathematical functions are available in R, like all of them. I guess the question is, how do you find out what a particular function is called in R? Any ideas? So somebody name their favorite obscure mathematical function that not too obscure, just somewhat obscure. Anyone? No, nobody has any favorite math function. Luis? Cosine. Okay, well, so there's a couple ways to do this. You can actually go over to the help prompt in the tab on the lower right. You can type cosine. And it'll actually go, I think this actually goes out to the, this is actually not so useful. Thanks, Luis. So let me go with trigonometric functions. Base trigonometric functions, you can find them that way. That is not how I would actually work, because I by default go to Google. How do I execute cosine in R? And the first page comes to trigonometric functions, and you can get basically the same help page that we got inside of R, but in a much friendlier Google style, in a much friendlier web browser. I'm sort of joking, right? It doesn't matter how you get there, right? The point is that you can basically do free text questions into the web and get back pretty good answers. So some people, I ran into this a lot when I was teaching math as an undergraduate. Some people think they should know all this stuff in advance. Nobody knows all this stuff in advance, right? Everybody I know uses Google to find stuff. So don't be ashamed when you're like, how many of you have ever had that experience where you're like worried about spelling, you're spell checking a document, and all of a sudden you realize that the THE looks wrong in the document? This happens to me just me. Okay. Great. There's always moments when you forget stuff. So just remember to use Google or some web search, and you'll be fine. So all sorts of comparison operators, and you can read through this on your own when you're interested in what it can do. Basically, it's a superb calculator. It also has this thing that I've already demonstrated, which is the ability to store values in variables and then integrate those variables into a whole workflow of do this, do this, do this, and then you can have a workflow that starts with a variable assignment and does a bunch of stuff for the purpose of doing complex computation. So I used to do web lab work, and I used to have to make up, yes, Jane, used to. Somebody who knew me in grad school is laughing at the thought that I ever did web lab work. I used to have to do the buffer calculations, right, on a sheet of paper. I still remember the 10% for the enzyme, and they have to get the concentrations and salts right. If you do enough of those things, it's actually worth just writing a little R script where you put in the input DNA concentration and you generalize the calculation so you can get the right answer out. And the way you would do that is you write everything with reference to DNA, a variable called DNA conc. I'm going to do a really bad job with this, but you can say, DNA conc is 100 micrograms per mil, and I'm going to do stuff to that. And then you can say, well, I need to, dilute it to such and such a dilution factor and so on and so forth. And you can write a little recipe here that just involves DNA conc. And then when you have 10 samples, you can go in and change DNA conc 10 different times. There's actually other ways to do that as well, but there's other ways to do that more efficiently. But honestly, like just writing down the calculations and being able to run them again means you're less likely to make mistakes. So that's sort of a daily use case for this kind of thing. If you ever had to do budgets, including household budgets, this can actually be really handy because when you make a mistake, right? Everybody makes mistakes. When you make a mistake, and you and your partner are sitting there going, one of us is wrong, or both of us are wrong, then if you've actually written, okay, this is, maybe I have a strange relationship, I can't tell, but my wife also knows R, and so we can actually convey our budget calculations to each other and peer review each other's, okay, I have a strange relationship. but it's really handy, right? It's good for calculating numbers. So, and documenting what you've done. The only thing I want to say about variables is don't use X, Y, and Z. Use words like DNA underscore conc or something long. And there's actually two reasons for that. One is it's readable. You can look at DNA conc, and if you know that this is a script for calculating DNA concentration level things, you probably have some idea of what DNA conc stands for. The other thing is in R, there's, I don't actually know if this works in scripts, but there's tab completion. So once you've defined DNA conc, by running that, you can type DNA and it will actually tap and hit tab and it will complete to the nearest unambiguous text match. So if you write long explanatory variables, you don't have to type them all the way out. You can actually just start them and hit tab. And this way you'll have both values, both the benefit of explanatory code in your R script and not have to type too much. I don't actually know what happens in scripts when you do this. I say DNA conc. Oh, it works in scripts. Okay, so if I'm in a script and I type DN, what it's actually doing now is it's saying, well, there's actually 4 matches. There's DNA conc, there's DNase, there's dnorm, and there's DN binom, which presumably has something to do with the binomial distribution. Density function for binomial distribution.
Negative binomial.
Negative binomial, thank you. So he Googled that. I don't know if you noticed. He didn't online, but I would have to Google that. And so you can then move up and down and select that, and in this case, I want the variable. So don't be afraid of long variable names. If you see a script, think about yourself in 6 months looking at a script, going, am I going to know what X is by the time I'm 50 lines deep in the script? The answer is no, you will not. Right? Okay. So there's this variable name conventions. You can use periods between words. You can use underscores between words. You can use this thing called camel case. It's called camel case because it looks like camel humps. You're writing a word and you have a uppercase, right? I personally prefer underscores, so you're wrong if you don't use underscores, but you can be wrong and use camel case if you want. Tab completion I've already covered, and then I also talked a little bit about understanding functions and getting help. So I think the hardest thing, the reason I keep on coming back to it, the hardest thing for people to get is that when they get exposed is they're lost in the sort of world of, I know I want to do something, I don't know what functions and R code to use to do it, and where do I start? Anybody have any suggestions? I have an answer for you for what I would do, but does anybody have any thoughts? How do you start? Does anybody have any words of wisdom on how they start doing an R coding project?
Start writing it in like plain language, English, what I want to accomplish,
right.
And then translate that into code.
Right. Start writing what you want to do in plain English and then translate that into code. There's one problem with that. Lisa's been doing this for a while now, so I think she's maybe skipped over this problem, which is that sometimes what you write in plain English isn't going to be directly translatable into R. And so how do you deal with that? So my solution is to steal other people's code. Right? So let me show you. How do I plot a negative binomial distribution in R? Okay. So this is a promising website, right? I instantly see, oh, there's a website that solves quick R. Awesome, right? It's not documentation, it's not a book. It says quick R, they know what I want. Okay, so let's see if, unfortunately, where are we? So it doesn't contain exactly what I want, but it does give me an awful lot of useful stuff. So, so here's this little bit of code that you can't read in the back, but it says, what proportion of children are expected to have an IQ between 80 and 120? I'm just gonna copy that and go back to RStudio. I'm gonna paste this in here. And they have all this helpful text that I'm gonna ignore because I don't care about the details yet, right? I just want a piece of code that works. I paste it, I get this great, I mean, this is awesome, right? Like, this is ready to go in a publication, right? So I'm sort of being a little bit jokey about it, but honestly, like everybody I know pretty much steals code, either from themselves or from Google. And that is totally legit, unless it says don't steal this code. But almost everybody I know like just puts code out. Like code like this is not something you would copyright or protect in any particular way because it's all based on. So that's my honestly, like, you can pretty much all leave now. My suggestion is Google stuff and run it. So, and here's a tip: if you Google stuff and you run it and it doesn't work quite the way you want it to work, you can come to our office hours and we'll help you get it working the way you want it to work. So, all right. So, what else do I want to say on here? Okay. So every now and then you'll see errors and warnings. So suppose I take a negative number, -1. And I take the natural log of a negative number. What am I going to get? Well, natural log of a negative number is presumably imaginary, but generally you would expect to get an error out of that. So let's see what happens. Warning message: in log a negative number, NaN is produced. Okay, so the answer is NaN, which stands for not a number. And the reason it's giving you this warning is you can actually give log what's called a vector, a list of many different numbers. And if some of those numbers are positive, it will give you the natural logs of those. If some of those numbers are negative, it will give you not a number for those entries. And you'll get a vector that's mixed between the right answers and not a number I could compute for this. So R will typically try to do the right thing to the data where it can, and then tell you when it can't, when it's running into problems with some of your other data. And I think there was also this thing, right? If you run this, it says error object negative number not found. Here I put in a variable we haven't defined yet, placeholder for a number that we haven't defined. So just pay attention to these warnings. I think when you're working with large amounts of data, one of the things that when you're working with more than like 10 or 15 rows of data, one of the things you'll find is that you run something and you get some warnings and you're like, yeah, but the output looks kind of right. And then only like 3 months later, when you're tracking down a weird dot on the upper left, right-hand corner of your plot that doesn't belong there, well, you realize that somebody did something bad to your data set and there's a misplaced decimal point or something, and R is just going to do whatever you want to that point. It's like with the spreadsheet. The biggest reason I try not to use Excel anymore is because I have this habit of typing things into random cells by mistake as I'm flipping through my various windows. And so I end up corrupting the spreadsheet. Right? Same thing will happen with R. It's just R will give you warnings like this rather than silently corrupting your data for all eternity. Not that I'm not a big fan of Excel. All right. So let's move on to talk about RStudio. So to get there, go back to this topics page. Go to project management, and essentially. One of the things I find really amusing about teaching this material, incidentally, is that it heavily features people from UC Davis. So Fitz Buffalo is a grad student over in the Ecology and Evolution program, and they decided to cite his tweet in these materials, which were written by a UC Davis graduate student. There's arguments about why you should do proper project management, and I'm just going to show you how to do this in RStudio a little bit, but I don't know how many of you have one or more directories on your hard disk that look like this. It doesn't really matter what the contents are. What you'll notice is there's a plethora of similarly named files. They're all in one directory, or they're all sort of mixed and intermingled. And I can guarantee you, having done this myself for a long time, that you will not be able to go back into this directory in like 4 years if you switch to another project and have any idea what any of these files are, basically. You might have some idea, but you'd be guessing. It's sort of a bad situation to be in when you're trying to like recompute on your data for a publication that was just rejected, or where things needed to be changed. So what we recommend is, right, so there's all these things like, there's all these arguments for a good project layout, and I'm going to skip over them. I'm just going to say you can use RStudio. If you're using R, you can use RStudio to help set up your project directory and manage your code and your data and so on together. So what we're going to do is we're going to go to RStudio and create a new project. It's called RStudio. So go to RStudio, go up to File, and do New Project. And in my case, because I have a bunch of changes, it's going to ask me, do I want to save what I've done, and I'll just say yes. What a new project is going to do in RStudio is open a whole new RStudio page and get rid of the old stuff. So you've either saved it or not. And you can do a couple different things. You can either start a whole new project, which is what we're going to do today. You can take an existing working directory where you've already done some work and encapsulate it in a project. And then you can also, if you're using version control and Git or Mercurial or Subversion, you can actually have a project that knows about version control and lets you track all the changes in all your files. And I'm not going to talk about this today. I have other workshops that talk about version control. But version control is fully integrated into RStudio, so you can use it if you're interested. So I'm going to click on New Directory, and there's one really important thing about this new directory. And I'm going to say empty project. And now here's the important thing. You have to be able to find this directory. Okay? This is sometimes easier said than done. Just make sure it's like in your user directory or it's on your desktop or somewhere where you can find it, because we're going to be downloading some files to put into it later. And if you've like created it in some never land where you have no idea where it is, you're going to spend some time searching for it. In this case, if you see a tilde, this tilde here means under your home directory. And I'm going to name mine. That's where I'm going to put mine. And I'm going to name mine tutorial. And then I'll click Create Project. And I get a whole new shiny looking RStudio interface with a new R console right now. Okay? And you can see over here in the file browser, you should see home tutorial. And this is basically empty except for this tutorial.r project file, which is sort of a description of the files and stuff that's in your R project. This is the actual R project itself. Everybody good? Please flag down a TA if you ran into any problems. Okay. So what we're going to do is organize our data organize our project like so. We're going to create a directory for data, and we're going to create a directory for code. And just for the heck of it, because creating directories is easy and fun, we'll create results and papers, although we'll mostly be using data and code today. Okay, why is there separation between data and code? Well, data is going to be your raw data. Data is going to be whatever you're putting into your R scripts. And that can be, that's probably not going to be, in the case of genomics, that's probably not going to be your FASTQ files or stuff like that. It's going to be the output of running your variant calling or your expression analysis or whatever. And that's going to be treated as something that's essentially read-only. You're not going to go in and modify those files. Those files you treat as sort of sacrosanct. What code is going to do is then take those data, the files in your data directory, work with them, manipulate them, and then output a nature paper. Right? I'm not a huge fan of nature, but you know, everybody responds to there will be a big red button that says run my code and produce my nature paper. Everybody sort of responds to that. So that's where we're going with this. Is there's going to be some paper output, and it can be just the figures for the paper, it can be the entire paper itself, or it can be a description of the stage of the project that you're at, and that's what we'll be talking about with RMarkdown a little bit at the very end. Okay, so let's create these, and to create these, go back to the RStudio interface and click on New Folder. I should say you can do all of this in file browser of your operating system. So you can go to this folder, you can go to this directory with Windows or Mac and do create folder, whatever. It's all the same to R. But in this case, there's a nice shiny button. So see that. So new folder code, new folder data, new folder results, and new folder papers. I like the optimistic plural on papers. Is that awesome? Like, yeah, this data set, I'm gonna get multiple papers out of this data set. All right, more likely it'll be like draft 1, draft 2, draft 3, draft, why did my advisor return this? Okay, so, and now we're gonna delete, we're gonna download a data set to the data directory. And so this is the tricky bit where you need to define where your project directory is. So go to this link, and rather than clicking on it, right click or control click. And if I control click, it will now open up a menu, and you do save link as. The exact wording may vary, but it's usually something like save link as. And I'm going to put this in this continents.rda file in the data directory. And since we're all doing it at once, it may take a little bit longer to do, but you should be able to go into your RStudio and go into your data directory and see this 317 byte file called continents.rda. This is an R data file. So it's basically been saved. I'm waiting for Chris to correct me in case I'm wrong about this, but it's basically been saved directly. It's called a data frame. It's been saved directly from R. There's no parsing involved. It's a file that R natively understands the contents of. All right, and we're going to load and inspect this data set next. So please put up a red sticky if you're running into any problems. Put up a yellow sticky if you're all good to go. We'll just do a sticky check. Okay, and those of you that are ready to go, navigate to the next thing, which is data types and subsetting. And we should be on this page. I'll just wait a second for people to catch up. Oh, Daniel? Right here. Oh, sorry, it's on, you put the sticky on the side. See, sticky placement. Sticky placement.
But this is here.
Okay. And there's somebody playing with the red sticky back there. It's on their forehead now. I don't know what that means. I think they're okay. See, now you're just trolling me. Video and audio. Okay. I invited you to the. It's actually the YouTube links on the page. Yeah.
Just a quick question. So does everything have to be RDA and CSV files, or can you use text files too?
You can use text files. Ask that again in a second.
Okay.
We're going to parse the CSV file in a second and ask that again.
Okay.
It depends. Like we can't load a text file that doesn't have like a spreadsheet style data set in it into a data frame. Data frames are explicitly for spreadsheet style data.
Okay.
But if you're interested in like text processing, then yes.
So we use Chime.
Okay.
So I mean, everything that comes out is either a text file or a file.
So a CSV file is a text file.
Okay.
It's just one with separators. So as long as it's that kind of format.
Okay.
No problem.
Yes, but so is that weird? The same thing. But when I have it in here, I'll get the data, right? Is that what you're saying? But when I so like you're downloading file as, but then oh, that's right.
So where are we saying having problems? Is it finding things or is it finding iron created? Yeah. Told you. Told them all. Nobody listens. It's hard, right? Windows. Puts things in different places. I don't know. Where am I?
So now what?
All right, looks like almost everything.
All right. All right. Oh, actually, I just there are cookies in the back. There's like the extra super unhealthy ones, and then there's the only slightly unhealthy ones that don't have sugar layered in between them. And we'll take a bio break in like 10 minutes.
Are you ready?
Yeah.
So what is the difference between creating folders instead of creating folders?
All right. Okay, it's on. Yeah, great. Okay. So there's a lot of details about how R works with data, and I'm just going to show you the basic, what I think is the single most useful construct in R, which is the data frame. In the data frame, I'm sure I'm going to get corrected for this at some point, but the data frame is basically like a spreadsheet in a single object in R. So what R lets you do is in effect load multiple different spreadsheets into one data frame each, and then lets you do things both within a data frame and across multiple data frames. So in order to load the file that we just saved, if you put it in the data directory, you would run this load data/contents.rda. And for Windows folk who are used to directory names that contain backslashes, I think this should still work on Windows. And basically what this says, it says this is an R, this is a file containing R variables, load those into my current workspace. So, okay, before you run that, is there anything that I should do? Anything?
Load the script.
Right, yes. Yeah, you were listening, right. Don't just run stuff at the console, but instead go up to File, do New File, and do RScript. And now in this RScript, I'm going to paste that, and then I'm going to execute it. Okay, so it was subtle. Two things just happened. One is it executed this load data comments.rda in the console. The other thing that happened is up in the global environment, a new little variable got created called continents. And that's because that was what was in the continents.rda file. You can go look at that by clicking on it up here. You can see some details about what's in continents. A couple other things just happened, right? This is a computer, so if you didn't click over here and have 8 things happen over here, then you're not having a good day. So we clicked on it, and it replaced my script with a view of the continents data frames. The continents data frame contains Oceania, 6 continents, estimates of the area, the population, and percent total population. Quick note. Does anybody notice anything about the names of the columns in that? Aren't they like super explanatory? Aren't these awesome variable names? They call them area, and you go, okay, well, is that area in miles or miles squared or what? It's like, no, it's kilometers squared, right? Because it's right in the name. Population, presumably that's people, and then percent total population is something you can calculate for yourself. So this is a data frame that looks suspiciously like a spreadsheet, but it's now loaded into R, and there's now a lot of stuff you can do with this. Go ahead, yes.
Is there a limitation on the number of characters for variables?
Is there a limitation on number of characters for a variable name?
Like if I have like 50 characters.
50 characters is going to be fine. I would worry if you started getting in upwards of a couple hundred. I would say that if you're storing your primary data as variable names, you've taken a wrong turn somewhere. You know, if you're like, that was not a very useful comment on my part. Yeah, you know, something that you can read, basically. But then tab completion gives you license to sort of make it as explanatory. And I believe if you make it super long, R will elide it or put it. Okay, so there's all sorts of things we can do with this data now that we have it. A couple of things. So you can just type continents. I'm actually going to type it in the console. You can just type continents, and it will show you sort of the text version of what's in that window up there. I'll show you the details. You can extract individual columns. I don't know if we're going to get to that. Well, you can take a look at what's in it. So you can type head continents. And what head continents does is, suppose you had a data frame that had 50,000 rows in it. Head would give you the first 10 or so. And it would let you sort of look at what's actually in your data frame, right? One of the main things you want to do with large data sets is sort of explore them interactively, just to make sure that they're not completely weird and wrong. There's this command called structure. I think that's what it stands for. It's called str. And str continents will say, okay, well, this is a data frame. It has 6 observations of 4 variables. So each observation is a row. Each variable is a column. So you have essentially a matrix of observations by variables. Continent is a character, area is a number, population is a number, and percent total population is a number, right? So it tells you sort of what the types of the columns are. One of the common types of errors that you'll run into is situations where somehow a bit of text snuck into your spreadsheet, and you'll end up with, and Chris, I've had this happen to me, and I think this is what's going on. If there's something that can't be converted into a number in a column in a spreadsheet, then R will label the whole thing as a character column in the data frame.
Sorry, is it the strings factors issue?
Yeah.
Yeah.
So it's always worth just doing this and going, okay, area should always be a number. Is it a number? Because this will tell you if you have 50,000 rows and one of them wasn't convertible to a number, this will tell you because it won't convert the whole column into a number, right? So it's always just worth looking at your data to see if R could do the right thing with it. If you have, I think the right term for this in the general sense is categorical data. Like suppose you only had 10 different values that are particular variable could take on. You just want to make sure that there are only those 10 different values in there. This is something I can talk more about later if you need to fix large spreadsheets where you're supposed to only have like 10 different colors, red, green, blue, and you had a lazy undergrad who mistyped things a lot. Then you can actually fix those in bulk using OpenRefine. Again, I'm happy to show you that. We have a whole tutorial on that as well. I can run you through. And then I'll just show you one more function, summary. And summary does this nice thing. It sort of scrolled off the screen, but summary gives you numerical summaries of your data. Right? So it'll say, okay, the quartiles, the median, the mean, the max, the min for area, population, percentile, pop, right? And that's a good way to check that your spreadsheet hasn't some corrupted value haven't snuck in where like, gosh, that continent sure seems small, right? Or wow, there's a continent that's 99% of the Earth, which is also would be a bad sign, right? So there's a ton of things you can do with what are called vectors, and vectors are a single variable or a single column from this data frame. I'm not actually going to go through them because I want to get to the plotting by the time right after break. But you can extract vectors using this $sign operator. So if you say continents $sign population, it will just give you essentially a list, an ordered list of the 6 values for the 6 continents that are in this data frame of just the population. So if you go back and you look at the continents data frame, what you'll see is that those numbers should bear a suspicious resemblance to the population numbers in this row, because they're the same. So that's how you can extract single sort of slices out of the data set. And you can, if you wanted to add a new column to this data frame, you could load in 6 numbers and then assign it to continents $sign your new column name, for example. There's ways to sort of mash together different data sets as long as they're all in registry with one another. It's a little bit dangerous to do, but it's something that you can do. Any questions? I mean, this is like a ridiculously fast and short overview of data frames, but I like to think of them as just as spreadsheets that you can do things in bulk to.
Could you do that on Excel and then import it here?
So absolutely, and we're going to show you the next thing we're going to do is import a comma separated value file that would come out of Excel. So that's where most people start, right? They have some spreadsheet that they want to do bad things to, or good things. Right? All right, so I promise we're going to get to a break, but I have to assign you a task before the break. And the task for the break is we're going to load a bigger CSV file. So this continents thing is nice, but it's a nice way to show data frames because it's only got 6 observations. But we actually want to work with a much larger data set for plotting and stuff. And that data set is going to be the Gapminder data set. And if you scroll all the way down to the bottom of this page, you'll see reading CSV data. And we're going to be working with is the Gapminder data set, which comes in a comma separated value file, which is something you can both import into and export from Excel. And it provides country by year level data on GDP, population, and longevity. And what we're going to do is we're going to download it and put it in the data directory of our project. So, and then what we're going to do is we're going to use this command, read.csv, and we're going to take all of the data in this, which is converted into a data frame, which is what read.csv does, and we're going to put it in the Gapminder variable. So we're going to have all of this data, I don't remember how big it is, but I think it's quite large. And it's going to be in this one variable called Gapminder, and we're going to do things to that involve plotting. Right? So, but we have to get that data file. And let's see, where's the data file? Okay, so your task, we're going to break in 30 seconds. Your task is to take this link, save the file as, put it in the data directory of your project, and then read the data with the read.csv function. If you get to this point and you want to take your break, you have my permission. If you really have to go to the bathroom, you can go now. But if you can get to the point where you save the file into your data directory and you see it in RStudio in the data directory, then you'll be set to go after the break. So let's reconvene at 10:50. There's coffee in the back. Bathrooms are second hallway on the left. And please feel free to flag me down or any one of the TAs if you have questions or problems at the moment. All right, so let's take a break. All right, I think, yeah, okay, awesome. So that was a tough question of how big a coffee pot you want to bring. This is very slow, and then the big coffee pot ends up mostly going to waste. All right, so how many of you, please put up a yellow sticky if you are good with the Gapminder, if you think you're good with Gapminder. And please put up a red sticky if you're running into problems or want some help. All right, so I'm gonna walk through downloading it myself. Here I'm gonna go to this link, and I'll click on the link. I'll do a control click, and then save link as. And this, rather than opening the file or downloading it to my downloads folder, what this does is bring up a file save box where I can navigate around. And in this case, because the last place I saved a file to was this directory data, it's also in the going immediately in the right place. I did want to say, at least on Macs, you can do this useful thing where you can click on the thing, and it'll show you the sort of hierarchy of folders. So I'm on my MacBook, on my hard drive, in users, directory T, directory tutorial. So if you're trying to find files, there's sometimes ways of, in whatever file finder you're in, sort of getting the sort of map to where you need to go. And one comment here is it's better to do this. So I'll show you some alternatives. So I'm going to run this save now. Okay. It's never entirely clear what's going to happen when you click on a file in a web browser. It depends on the web browser and on the operating system. So sometimes if I click on this link, in my case, I believe, okay, so here it opens it as a CSV file. This is if I don't do this control click and save as. If I open it as a CSV file, now I could presumably go and do a file save as. Maybe you know, I don't actually know what happens when I do that on this file. Let me try this. Save page as. Okay, so in this case, it gets the format right. It says this is comma separated values, and we'll save the file properly. But there are many other file types where, and we'll actually see one in a little bit when we get to RMarkdown, where when you do this and you just do save as, it will try and append a file extension to it, and it will sometimes change the format of the file. So if you do that control click or right click save as, it doesn't change the file format. It just downloads exactly what's on the remote website. And this is important for data, because sometimes if you load data into your web browser, you'll do things like put new lines, endings on it, or if it's binary, it will do horrible things to like text that has weird characters and so on. So it's better to do the save as directly. And if you're familiar with command line work, that's why we use wget or curl at the command line rather than saving things to your web browser. Okay, so we have this file. And what we're going to do is now load it into R, and I'm just going to copy paste. Okay, so I'm going to copy paste this Gapminder read.csv. Why would I copy paste? You've seen me type. I'm pretty fast. I make mistakes only like 20% of the time. Why would I copy paste? Because I still make mistakes, and because my ego is not invested in my ability to type fast. Right? Like this is not like a skill that anyway. There's this weird thing where people like really want to do everything themselves, and it's like, no, just cheat. Like this kind of cheating is totally okay, right? It gets you to your result faster. So I'm going to copy that, and I'm going to go to R, and I'm going to go back to my script, and in my script I'm going to paste this, and I'm going to run it. Okay. It ran, no errors. Does that mean I'm good? How else do I know? So the answer is I am good, like this worked. How do I know that I actually loaded this data set? Are there any other signs? How would I find out?
It came up in your data.
It came up in my data, right? Any other things I could do? So no error, right? I could also just type, I could also start investigating it, right? I could use those commands we just learned, like head Gapminder. All that this does up here is tell me I have 1,700 observations of 6 variables. I could look at those observations, right? I can click on that up there. Click on Gapminder, and you'll see this looks pretty good, but you wouldn't necessarily know that all the data values were correct, right? You wouldn't necessarily know that it hadn't failed to convert some numbers from text to numbers, that kind of thing. So that's why you always want to do not just a head of Gapminder here, which shows you, okay, the beginning of the file looks good. If you're super paranoid, and I've been doing this since like the late 80s, so I am in fact super paranoid, or the way I like to phrase it, realistic. What you could do is be like, hey, I wonder if that's what the first line of the file actually looks like, right? So every now and then it's worth like just checking. Oops. Okay, Afghanistan 779.445 on the end of the first line. Excellent. Numbers match, right? You might be thinking computers never make mistakes, right? And that's where you're making a mistake. So it's just worth checking. And the other thing that we want to do is we want to do this STR, which I think stands for structure. What STR will tell us, and it's a little hard to see because of the way the font stuff works out, is it has 1,704 lines, 6 variables. There's country, it's a type called factor, which means that it's essentially categorical data. There's year, which is integer, population, which is a number, continent, which is again a factor with 5 levels, which means that there's 5 different continents. The country factor has 142 levels, so there's 142 countries. Life expectancy and GDP per capita, which are both numbers. So that all looks good, right? Those all look like the things that I would expect those columns, those observations to look like. If you're wondering why I'm emphasizing this, I'm just going to say it again and again. Most of the mistakes that I make, other than most of the technical mistakes I make, are at this stage in the project. The data's in the wrong format, whatever. The conceptual mistakes, they happen all the time, right? There's nothing I can do to guard against those, but run it by other people. The sort of stupid, like, oh, I left a comma in and now all the numbers are messed up kind of mistake is something that you can sort of guard against here. That's why we're going to get to plotting. Okay, so let me go back to the tutorial. Okay, so now I'm going to talk about plotting. So looking at your data, awesome, you should totally do it. We're going to use a ggplot, and there's sort of a split within the R community. I think most people view ggplot as like the right thing to use now, but that's what this tutorial does. There are other plotting packages in R. What do I maybe show you today? It's just one of them. So, and you'll see why it's both super cool and super horrible as we go through this tutorial. Like, it either just works or you're like, I have no idea how to make this work. Luckily, there's lots of code out there that you can crit or steal to make things work. So the package that we're going to be using is actually not just ggplot. We're going to be using tidyverse. I think for today we're only going to be using ggplot2 from it, but there's a whole collection of packages that used to be known as Hadleyverse. I guess Hadley Wickham had written most of them or designed most of them, and he's calling it tidyverse as a super package. If you're interested in things like large-scale manipulation of data sets and filtering and combination and other things, dplyr, so on, and cleaning up data, tidyr and dplyr are very useful tools for sort of mass cleansing of large data sets. We're mostly going to be using ggplot2. The next thing you should do is run this install.packages, and you only need to run this once, so you can actually put it in your console. In my case, I've already installed all of these. I guess a new version. But anyway, there's a slightly new version of it. You can either install things with install.packages, or you can go up to, where is it? The file. Where's install packages? Install packages, which is over in tools. So I can go to tools, install packages, and I could type tidyverse and click on install. Oh, it didn't autocomplete, right, okay. Tidyverse. Oh, it autocorrect. Okay, right. So now it just basically runs install that package. If you ran into an error at this point, please put up a red sticky. You'll be unable to do stuff. Excellent. Wow. Okay, I don't believe you all. Somebody's hiding a failed install. Okay, or not, in which case this worked better than any other workshop I've ever given. All right, you're awesome. So now that we've installed the packages, which again, you only need to do once, unless you want to update them. Now we're going to use this. This command library. And what library does, library is something that says load in all the functionality provided by these packages. And you need to execute this for each script that uses the functionality of this package. So if you want to use ggplot2, you need to do something like library tidyverse or library ggplot2 at the beginning of the script or before you use it. And this is because each library takes up some amount of space, memory on your computer, and also there's such a conflict between packages. So there's something like, I read online, 7,000 R packages. There's an awful lot of R packages out there, and some of them conflict with one another, and certainly don't want to load all of them all at once. So here we're just loading the ones we're going to use, which is ggplot2. So you need to run this, and when you run this, so we're going to put that in our script, and run it. And it will say loading things, and then at the very bottom will say conflict with tidy packages. And basically what happens here is that the filter function and the lag function are both defined in dplyr and the stats package. Dplyr overwrites the stats package version because you've loaded it most recently. All right, so let's get a plot. And there's the potential for there to be a font problem for people here. So if this fails, just put up a red sticky. So what we're going to do is we're going to start with a plot. So just copy and paste this. Oops. And then run it. And you should all get either an error or this. I'll explain this plot in a second. So could everybody who sees a plot like this on their screen? Did you get a font? Did you get like 20 warnings?
Yeah.
Okay.
Errors, highlight errors.
So this is the problem I ran into yesterday, so I'll come help you in a second. So please just put up a yellow sticky if this all works.
Yeah.
Okay, so that's not bad.
Yeah, when you ran install.
Yeah.
Correct. So now you're trying to.
It was yeah. But I don't have the latest version of the operating system.
That should
So what you may need.
Mine takes a little bit.
Last time after this, there was one.
So I don't update Mars in the super latest version.
So I didn't do the super latest because it's like it's really an operating system that was.
Yeah, that's good.
So I will. So I did this one. Snow.
So copy paste. So it looks so much easier. Yeah. So the packages that are already installed on because I think what's happening is
Deadlist versions, tidy version requires this updated program called Color Space, which just got updated as well. And unless you update everything else.
It's just a little bit.
You can do that. Yeah, you should. You're probably about 3 or 4 versions. So you don't need to. Once you start getting rid of smart. Yeah. Right.
Just do stuff up.
I just cannot install package Teddy Rose, Teddy Bruce.
You just do this.
I know what that is. So what it was requiring was,
You'll do that through the.
just tags. It just says,
Yeah, so that's good.
just version of RStudio.
Yeah, I'm not recommending.
Please give it.
What's the difference between writing here and writing here?
Go to one that's saved here, whereas down here, just the computer.
So I think when you say this.
She's running.
Yeah, just structured.
Exactly. I think I guess you use it more. No, I have that.
I'll come back to you next a little bit. Make sure it's working. So.
So do you install that in the RStudio and then go back to the station? All processes that run install in the RStudio. Right up in there, and it's the RStudio contacts. You can use our console for all that, just have a copy. So, and can you move to the side?
All right, so I'm gonna, how many people are still, okay, I'm gonna answer a couple more questions first.
So once I install something package, in our console, I can reach that to task. Okay.
Yeah, usually they are.
So what can I can not use these packages?
Because usually the RStudio it doesn't have a communication cycle. It starts and they're very so the communication is
Not good.
but maybe just because they are trying to present things because that's what RStudio wanted to say.
Try to just put it on.
Now is there.
Has it moved?
Doing something.
Okay, good. So it should just click right there.
Thank you. I'm gonna just do it.
Why?
As you can tell, this is all an elaborate plot to get you to have an R installation on your computer.
Okay, thanks. Yours.
Yeah, finished. Now I can do the library. Thank you.
It's 4 versions of old operating system. Nothing is working.
You just don't want
Okay. It seems like things have quieted down. There seems to be only like 3 or 4 people who can't be installed. So I'm going to move forward. And then we're happy to help you either after this workshop or at the office hours, I guess, next year with install problems. Okay, so what is this command doing? So you have ggplot gapminder AES x equals GDP per cap y equals life expect plus g on point. Right? Plus is not doing addition here. What it's really doing is composing things. Don't worry too much about it. There are 2 schools of thought, the right school and the wrong school on how to think about commands given to a computer. The wrong school is the one that says, before I move forward, I need to understand everything that's going on here. And the reason that's at least unproductive is that computers are weird and they don't think like humans, and the object is to get them to do the right thing, not necessarily to understand how they're doing it at this stage. So instead of obsessing over everything here, what I would try to do instead, what I would suggest doing instead is thinking about it from a constraints perspective. Okay, so we have a plot, it has GDP per cap on the x-axis, has life expectancy on the y-axis. You know, if you look at this command, there's only 2 pieces of information that you don't necessarily understand, right? There's ggplot and there's g on point. You can probably guess at what both of those commands do. What I'm really saying is, you know you want to plot the gapminder data set. So if you want to plot a different data set, put that different data set there instead of gapminder. You know you want to plot, you know you're plotting the GDP per capita on the x-axis, so you can guess that if you put a different variable there, that will be the variable plotted on the x-axis. And the same for the y, right? So basically the way I treat these commands until I have a great deal of experience with them is as black boxes that are magic, and I poke them until they work. And then I leave them alone and back away slowly. And the great thing about R and reproducibility is that I don't have to remember this command to type it in again. It's in a file that I can run. So I never need to think about it again if I'm happy with this, right? Of course, we're never happy with plotting, right? Because plotting is all about getting the things to look exactly right. So that's what we're going to be talking about. The sort of short version, now I'm going to ignore my own advice and try and tell you a little bit about what's going on. And it's a little bit of a mind-altering system. And I'll just say, what ggplot does is it separates the logic of what you want to plot where from how to plot it. So there's the statement that I want to plot something where the x-axis is the GDP per capita and the y-axis is life expectancy. And then there's going to be a variety of details about how you want that plot. Do you want to plot it as points, which is what we're doing here? Do you want to plot it with colors? How do you want to set the colors up? And all those things are going to be in different places in this command, and that's what I sort of want to get you used to over the next 20 or 30 minutes of commands. Okay. So where's Chris is over there, so he'll step in maybe help. So, okay, so what we've got here is a plot of life expectancy versus GDP per capita, which I think shows you it's actually a little large, because I'm not in RStudio, which shows you the slightly depressing fact that we already know, which is that the higher the GDP per capita, the longer the life expectancy per country. So you do see there's a couple of points out to the right that are heavily biasing. Presumably the US and some of the Scandinavian countries are out there. Yeah. So this next thing here is an explanation of what I just said. ggplot basically sets up the canvas but doesn't draw anything on it. You need to tell ggplot how you want it to draw the data on the canvas. And that's what the g on point does. Another helpful tip is that there's this AES function, which stands for aesthetics, which is this mapping of variables to plot elements. And the key input point here is that arguments to this AES will be whatever variable names are available in the data.frame. You're sort of restricted to the data.frame that you're plotting. Data from. So, okay. So we won't do this challenge yet. We'll do another one in a second, but changing a variable. So how would you change this code to make a figure that shows how life expectancy has changed over time? So first of all, what variable within the data frame are you looking for? Any suggestions?
Years.
Years. So how do we know that that's in the data frame? Well, we have a variety of ways of looking at that. We can actually click on Gapminder and we'll see that there's a year there. Second column. Okay. So now we know that we want to replace something with year. And what do we want to replace? These are not trick questions. These are just simple questions. So what do we want to replace?
X variable.
We want to replace the X variable. We want to set it to year. Was it year or years?
Year.
These things matter. Okay. So let's go in, go back to our script. I'm actually going to copy and paste this and make another one. And I'm just going to replace X with year and run this. And now I have this. So this is a little more hopeful than the last plot. You can see that there's generally a trend, right? That the spread of dots is, can't really tell too much about it, but you can see that the spread of dots, at least the minimum, seems to be going up steadily until it sort of stops. You can't tell anything about the distribution from this kind of plot. All you can really see is the min and the max, and maybe in some cases a little bit about the density, and you can also see the outliers. So still using points, just we've swapped out the X values for the year instead of GDP per capita. Okay. So let's do this bonus challenge. So and we'll just do it together. So suppose we want to show it by continent. We want to add continent on. Something that we can do here, we can't add another like axis, but we can use color. So logicking it out, looking at this command, where would we put color? Potentially in here. There's no reason you should know this, by the way. I'm asking you to wildly guess. That's okay. The computer will not explode if you type the wrong command into it, generally. There's a really small chance. And generally laptops, never mind. Okay, so where, right, so there could be in the point part, but remember what we're doing here is we're relating a feature of the data set to a character on the plot. So characters of the data set always go in that AES. At first blush, or by default, go in the AES. So any suggestions for what we should add in the AES? We want to have the color, and we want to put in continent.
Color equals continent.
Yeah, so let's just try this. Color equals continent. Now you get this nice plot. Life expectancy is generally lower in Africa, so you see a lot more red points in the bottom bit, and then up here are America, Europe, and Asia, which is spread out. Right. So this is the process I go through when I'm trying to, when I'm doing plotting, what I do is I go find a tutorial like this, and I steal the bits and pieces of information from the tutorial that seem to match what I want. So we probably, let's try adding trend lines. So we could just add lines between the points. There's a problem with that though. The problem with adding lines between the points is that what we're doing is adding a point, we're adding a connection between each point and the next point in the data set, which doesn't necessarily make any sense. So you get, in this case, it's by the lines it's grouped by continent, and so you basically see lines of the various colors between 2 points, but these points are randomly chosen. They don't actually indicate anything about the trends. They just more or less wherever the points are in the data set is connecting to them. So you can see that if you can regenerate this by adding geom line. In this data set, this is not a good way to look at this data, right? This is not particularly informative. You have lines, you can't see them unless you look down at the bottom, but you actually have lines between each of the different data points. There's a whole bunch of lines in here. They're sort of overwriting everything. What you really want to do is you want to tell the plotting system to plot between a group, to plot the trend lines for entire continents at a time. For example, you could do it by other, you could do it by country, you could do it by other things. So let's see if we can do it by continent, I think is the thing in the tutorial. So, right, so sorry, we want to do it by country. So here's something that's a little bit strange to think about, but you can add this group equals country, and what the group equals country does is it says, okay, when I'm asking you to connect line, when I'm asking you to connect lines, basically have the natural set of groups in the data set be pulled out from the country variable. So if there were 2 country variables, so if your data was in the wrong form, if there were 2 country variables for 1 year, if there were 2 identical country, if one country is represented by 2 points within a single year, you would still have a line, a vertical line between them, right? Because you're grouping by country. But here, that doesn't happen in this data set because it's a well-formatted data set. So instead, what you have is the trend lines from country to country from same country from year to year to year to year, and all of the other attributes like color of the continent the country's from follow along with that. So what group equals country does is it tells R or ggplot in this case to go by groupings to group points and connect points by the country they're from. And let's see if that works. Okay. It's not very pretty because of the way I have the there we are. Okay. Let's see what else I'll say. I think it's worth noting when you look at this command, note how we've broken out the plot. Things to think about at sort of a meta level. We've broken out the things to plot. There's a different property associated. This is an information-rich plot. We're representing 4 different kinds of information on one plot. We have the X value is the year, the Y value is the life expectancy, the color is the continent the country's on, and the group and the trend lines between are the country. You generally wouldn't want to duplicate things in that AES because then you'd be representing the same information in 2 different ways. Chris, so, okay, and now I'm going to go back and I'm going to roll back what I said before, which is that all of the different things should be within the this master AES call. This is the master AES call, but you can also color points and lines separately by placing AES or aesthetics within the individual points or lines or what happens. So in this case, we're going to make the points, have the points remain black because that's their default color. We're going to remove color equals continent from here, so it's not going to apply to the geom point, but then we're going to add this color aesthetic to the geom line and split it out from the points. And you get exactly what you'd expect at that point, which is that instead of this plot where you have all of the points are colored by the continent that they're on. Oops, let me adjust my. We can get instead AS color equals continent. from here. That works. Right. And now you get what I promised, which is the points remain black and the trend lines are now colored. So this is becoming pretty informative. You don't have the points stepping on each other, which we did before. Right? The objective of getting rid of the color of the points is that it didn't necessarily mean that much because the points are really high density, so they're overlapping with each other. So we've gotten rid of the color from there, and we just put the color on the trend lines. So you can look at this in the overall sense you can get is yes, everybody's improving, but some are improving less quickly than others, I guess would be one summary statement. I know someone once went in and looked at these two points, and that's something that we can look at using some of the tricks that I skipped over in the previous section of the tutorial, where you can go into data frames and say, I want all of the points where the life expectancy is below, say, 35 and the year is greater than 1970, or below 37 and the year is greater than 1970. Give me those columns, and then you can identify exactly which countries have those, right? And that's good practice too. You look at this plot, and the only thing that really stands out, other than the overall trends, is that there are these dismal points where life expectancy is really dropped. So you want to go find out, is that a data error? Or is that in my spreadsheet? Is that actually in my data set? And then generally, in this case, you want to go and do some news searching to find out what happened in those countries at that time. I have a suspicion that this might be Somalia. We can, if I have time, we can take a quick look at that. All right. So the thing that always bugs me about tutorials like this, of which I get a lot, is how quickly things start to move. So now it's like, hey, you have all the elements to do whatever the heck you want with the plot, so just go nuts, right? And so the strange thing for me about ggplot is that it actually kind of works that way, because, well, you'll see. And just one last point is that the order in which things are drawn is the order after the plus. So here, if you switch G on line and B on point, the points get drawn after the line, so the black sits on top as opposed to before where the lines were underneath, were on top of the points. Okay. So, question. So we've plotted numeric values on both axes. What if we want to plot a numeric variable against a categorical variable such as comment? So we want to know what's the distribution of life expectancies by continent, rather than across, rather than the way we've been plotting it so far. So we don't necessarily want to do a bar chart or a dot chart, because basically you're summarizing the heck out of the data, right? You're taking dozens or hundreds of data points, you're collapsing them down to one or two values, depending on whether they put error bars. That's generally sort of a statistical no-no, because, well, let's be blunt, reviewers look at that and they don't actually know what the spread of your data looked like. They don't know if you took 2 points that were very far apart and averaged them into the middle, or if you had mostly a center distribution of points and 1 or 2 outliers, or what. So one thing you can do is make a box plot. So let's do a box plot. And to do a box plot, you literally take away G on point and G on line, and you say G on box plot. And it knows, it goes, okay, well, you have these variables and you have these components of your data frame, and I'm just going to plot those. So a box plot. So if we do that, box plot, and this now is better because you can see the outlying points outside the box plot. Right? You can see the distribution of the data. It'll place the dots that don't fit within the various quartiles well outside them, and you can sort of get a sense for how well the box plot summary represents the overall data. So I think the interesting things that you would take away from this, one is that in Africa, the average life expectancy is quite low, and the distribution about that is quite low. But there are some countries that perform much better than others. For example, I would assume that South Africa is probably up here. It's one of the points up here at the top. And then you have the reverse situation for Europe, where you have, on average, a very high life expectancy. Then you have a number of countries that perform quite poorly. Quick question for you: is this across? Which year is this for? Anybody? All of the years, right? Because we didn't say to do anything by year. So this is somewhat given the trend lines that we've observed, right? This is actually an inaccurate representation of the data. We're going to roll with it, but I just want to make sure you understand. It's not like, oh, they must mean like this year. No, it's just going to take all the data and stuff it into the box. Okay. So, question for y'all. You've all seen violin plots. Assuming the existence of magic, how would you make this into a violin plot? Anybody? Any thoughts? Okay, you can cheat and you can Google it.
Can you change box plot to violin plot?
Change it to violin. I think it's just violin, but yeah.
Yeah.
Change box plot to violin. So let's see what happens. And there we are. So we just changed box plot to violin, got this. The slightly more principled way of doing this would be to search how do I do a violin plot with ggplot2 on Google. But there's no harm in guessing or even just using tab completion. So if you want to use tab completion, you could actually go back to the geom violin, geom underscore, and hit tab. See, this isn't so useful because there's so many of them. But if you just don't remember the name that you should use, you can scroll through this quite quickly. I'm going to stick with violin. All right. Okay. Can we color each violin by its continent? So conveniently, there's a fill aesthetic that goes into AES. We haven't used that before because so far we haven't anything we're filling except for the box plots in the violin plot. So where would we put a fill aesthetic? See, we want to put it on continent. Where do we put the fill aesthetic? Any suggestions? If you're wondering what I mean by aesthetic, I have no idea either, but it's what they mean when they say AES. That stands for aesthetic. So with that hint, where would you put color equals continent or fill equals continent? Within the parentheses of the aesthetic, right? Bear in mind here, I don't know R, right? Everywhere I've gotten in my R programming life has been by reading examples like this and then tweaking them until they worked. So the first thing to try is exactly put the fill equals continent in that aesthetic command. Fill equals continent. Let's see what happens. Isn't that pretty? Is there anywhere else we could have put it? Yes, please.
So one of the things I find is odd is like before we used color equal country, and this time we, or continent, this time we use fill, like.
Excellent, yes.
Way of knowing when those oddities come up.
This is why I always copy and paste from examples, because I have no way of knowing until I've used it for a while.
Yeah,
But let's step back a level. How would we find out?
I would try color equals continent.
Excellent. You would try it. Because again, your computer is unlikely to blow up in front of you. Extremely unlikely. I don't want to overstate it. Right? So just try it. I don't know what, I have a guess as to what's going to happen. But that's because I'm a programmer. And that's an unfair advantage or disadvantage depending on. So let me try running it. Yep. So the reason we used color before was because we were dealing with things that didn't have a fill. We can separate fill from color, from the drawing color, basically, is all that's going on here.
So fill and color are common features within ggplot in general.
I believe so. Yeah. So suppose I'm going to do something bad here. I don't think it's going to work. I'm going to just try it. Computers don't explode generally. Any ideas what's going to happen if I do fill by year? I have no idea. I don't know. All right, so what happened, Chris?
What was the output? Was there an error?
That's a good question. No, just ignored it.
Yeah.
Doesn't really know what to do. I think because I didn't do any group buys or anything. So it just doesn't do anything. So the flip side of this being sort of magical is that when things don't work, you don't necessarily have a clear idea of why. And that's why I highly recommend going to sites like this. I just Googled ggplot2 gallery. And if you want to know how to make beautiful plots in a variety of ways, basically you come here and you, okay, never do a ring or a donut plot. You know, density plot with ggplot2, I click on it, and here's the code to create that density plot, please.
Also, there's a resource called a ggplot2 cheat sheet.
ggplot2 cheat sheet. Oh, cool. Yeah. And so if you end up using ggplot2 a lot, you just print this out and put it up next to your computer.
If you go to RStudio and help, there are direct links to all of the cheat sheets that RStudio makes.
Right, because this is actually an RStudio cheat sheet. So you would do that by going into help.
Help and then cheat sheets.
It needs to be, does it need to be down here? There it is. Oh, look at that. Data manipulation, keyboard shortcuts, sorry, data visualization, RMarkdown, RStudio IDE, all sorts of other things. Yeah. It's almost like they expect people to use them. All right. So let's go back to our first example. Sort of foreshadowed what I'm going to do next by pointing out that this is sort of a lousy, this particular example is a lousy way to represent the data, right? Show the data. And the reason is that there are these outliers. What's the solution for outliers in plots? What's an initial solution for outliers in plots? Log transformation. Right? One of the first things you do is see how bad the situation is. Right? So how would you do a log transformation? So this ends up being a sort of a display parameter. And so you can add the scale x log 10, which basically does what it sounds like. It scales the x-axis with a log base 10, and that will generate this plot. So I'm just going to copy and paste that in. Do a plus. Now you can see that the outliers are still there, but you see a much nicer spread of all the points down here.
Why take the plus?
So the reason to do the plus is because it's an additional transformation of it's another composition layer or an alteration of the data. You're essentially providing directions to scale the x-axis in such a way.
But
So-
it could have been a caricature.
No. So the way ggplot, every time we've been adding something to ggplot2, we've been using a plus, because what we're doing is we're saying, here's the basic data set. Now give me the points, give me the lines, give me the x-axis scaled in such and such a way. And there will be other transformations like that. So it's all operating on this one plot. So this is actually atypical when I use Python. For me, when I use Python plotting, which is what I normally do, you like create a plot and then you successfully modify it by adding things to it, and then you say display the plot. With ggplot2, it's all in this one one line in effect with additions on. So you can also do things like add linear fits. So basically, this we're going to use this geom smooth extension, which just runs a linear model through the data. And I'm going to have a question for you in a second about it, but let's just get this plot up. Those plus smooth method equals ln. And when I run this, you'll see the linear fit. So suppose you wanted to make a mistake and you wanted to apply this linear fit to the data pre-log transformation. Any thoughts on how you would do that? How would you modify this command?
Wouldn't you just get rid of the plus scale?
I still want to display it on the log, but I want to do a linear fit to the raw data.
It needs to go before.
Right. I don't. Let's try it. I honestly don't know, but I'm guessing, given everything else, that that's how it would work. So actually, we could probably, and this may not work, but what the heck, probably have a second linear fit in there. Oops. Did that work? Or did geom smooth know? I think it knows that we're doing a log transformation. Let me go back and get rid of the second one. Oh, it doesn't matter in this case which order you put it in. It's not. It's saving you from yourself. I can't think of a situation where you want to do what I described. Sort of interesting to see what happens. So, like with all magic, sometimes the order matters and sometimes the order doesn't matter, and you just got to try it. But I think the real meta lesson here is just try stuff, see what works. If you think the analogy that I always like to use in programming is controls, right? Work with a data set where you know what the answer should be, and then make sure that your manipulations and your display of that data set match. You can even use like published data from somebody else's paper, which is a good check on their paper as well as on your methods, right? And make sure that when you're working with a data set where you know what the answer should be, you can get that answer using whatever methods you decide on, and then apply it to your new nifty cool data where you don't actually know what the answer is. And I would call that a control, right? I'd call it using a positive control generally. So you can also do all sorts of fun things. You can modify the appearances of the plots by here. There's a bunch of different themes that you can add on. This is the theme BW, which removes the gray background from the plots. And I think let's see what other things I want to put in. Okay, you end up with, instead of the plots with the gray background, you end up with the plots with the white background. So, is there an XKCD theme for ggplot2?
Yes.
Yeah. Do you have to install it?
I think you can. It's part of the GG themes package.
So let me see if I can change it. Do you think it's going to be theme XKCD?
Sure. You have to load it. Oh,
Okay. Well, this got a little more involved than I wanted to. But if you want to draw plots that look like they're hand drawn, there's actually themes to help you do that by introducing jitter into your lines and making it look like you've hand drawn the text. Right? I know people whose goal is to get this kind of thing into a published paper. I don't know if any of them have succeeded yet. But yeah, so there's a lot of themes out there. You can spend a lot of time getting stuck on themes. I have people in my lab that have very strong attachments to particular themes, and woe betide the person who like wants to suggest their color choices are maybe not the most appropriate for, you know, there are worse things to have arguments about, I guess, but there are also better things to have arguments about. So let's see, what else do I want to say here? Changing fixed aspects of plots, dashed lines, right? I'll just show you the, I'll just show you multi-panel figures. So we already did this thing where we're looking at the change in life expectancy over time across all continents in one plot. Just paste this in. Why is this not? Right, so we saw this plot, and it doesn't really help because you sort of have to mentally disentangle. You can sort of get the general trend lines, but there's some details going on in here, and I can't quite tell if this is red or if this is green or yellow. And then there's really weird changes in the red lines. Let's see if we can split those out into separate plots. So the way to do that is to facet the facet by continent. And this basically, what the facet argument here is doing is it's saying, give me a different plot for each different value of continent. You don't want to do this for a plot for a situation we have, like, you don't want to do this by country because you end up with 142 plots. Right? Depends. If you think your advisor will be impressed by that, you could try that. But a more useful command is probably to do this facet by continent. And that does the nice thing of breaking it out by continent. And you can see the plot lines are all the same. I think the colors are the same, but now they're broken out into different plots. So a fun aspect of all of this is that you can very quickly and easily try out many different types of manipulations, and you can relate them to each other, different plots, and you can relate them all to each other by sort of specifying the properties and how they're going to relate to the presentation of the data. And then you can just tweak whether or not you're showing points, lines, you're faceting, and other stuff very quickly and easily. So it sort of enables exploration. At the end of the day, though, what you have is something that, for those of you that use Excel, might be a little bit mind-blowing, which is you have the ability to make essentially infinitely many plots very, very fast. So I highly recommend for those of you whose advisor is not in the room, that what you do is not tell your advisor you're using R, and then pretend that each plot takes like hours of painstaking labor. So otherwise you'll find that they're spending a lot of time telling you to fix the color and change this and change that. And it's much easier to just pretend that it's all in Excel. It's really hard. My anecdote is I knew it was time for me to graduate when the most common comments on the data I was showing my boss were, my graduate advisor, were the colors are wrong. Right? It's like, that's the easiest thing to change. I think he didn't necessarily understand that it was super easy for me to change. And then I made the mistake of changing things super easily. Then he got used to that. And then when things didn't go that fast, he's like, why are you being so slow today? I'd be like, because you asked me to do a 48-hour computation in 2 hours. Anyway, so there's advisor management strategies that you should consider if you start to use lots of automation like this. My lab has it bad because I know they do all of this. So. All right. So the last thing I want to say is you can save these plots however you want. You just specify the kind of file type you want. So in this case, it's a .png, but you can also do a PDF and so on. And so I think many of you already know the difference between like a bitmap format and a spectra format. For high resolution images that are results of data plots, you generally want to use a PDF or something for publication quality because you can sort of zoom into those indefinitely or infinitely far because they're specified as lines and fonts rather than as points on a fixed resolution. So you can do this if you want. We have this convenient save results directory. I'm going to save this latest one. And this is how you can generate all the plots and then sort of scroll through them in your file browser. In my case, if I go look at files, there should now be files. I'm going to go to tutorial results, and you see this plot. And obviously, this plot needs to be modified, and you have to specify the width and so on that you want to save. And that's what the next section of the tutorial does. So mostly what I wanted to say is that this capability exists. It doesn't just work for thousands of lines, it works for hundreds of thousands of lines of data. If you're doing geometry analyses, if you're doing, whatever it is you're doing, as long as you load it into a spreadsheet type format, you can get into get it into R using the read.csv format. And then the goal really is to sort of build up your analysis by loading it in, doing the different plots, saving the plots, and presenting them as evidence along the way, as well as doing whatever statistical analyses you end up wanting to do. So what I really wanted to get to, and we have about, I think I'll go for another 15 minutes on this, is that many people would stop at this point and say, okay, well, I have this code, this R code that gives me the plots, and then I can run and I can modify, and if I need to change things or clean things up, if I need to remove points or add points or aggregate data sets or filter and so on, I can put them in and I can make a new gapminder data set and just rerun everything. And I'll show you that with Jupyter Notebook next week, those of you that are coming to that. But then the plots end up being disconnected from the code that you use to create them. That is, think about the scenario where you make these plots, and then you take them and you put them in a paper, maybe even, Lord forbid, a Word document. And the Word document has the plots in them. And then 4 years go by, and your advisor finally submits that paper for publication, and you're on like postdoc number 2 across the country. Your advisor says, okay, we need to change the color of this plot. You have 2 choices. You break out Photoshop, wrong choice. Or you go back and you find this code in your data, which you've archived in some way, and that's where version control can come in. Generally, I would not suggest leaving the archive with your advisor. That would be the wrong person to rely on for data persistence. And then you just rerun everything and you change the color, right? You force the color to a different color, and then you send them the plot. And remember to wait like 2 days before responding. So the problem with all of that is that you have to connect the data and you have to figure everything out. And if you lose like this code, it's a problem. And ultimately, the publication is the figures in the publication are disconnected from the code and the data that were used to create the publication. It's annoying. So rather than doing sort of traditional scientific workflow where you take your data and you make these plots of it, and then you sort of like put that aside, and you have the plot, which is the primary scientific product, plus your interpretation of the plot, plus whatever you squeaked by peer reviewers. It's sort of a nice idea to think about conveying this in more of a notebook format, where you think of it as your data analysis notebook, except it can be in electronic form. And you can integrate discussion of the results with plotting, with the code used to generate the plots, with the plots themselves. That's what I want to show you with RMarkdown. This is going to involve the installation of more software. So if it doesn't work for you, I'm going to ignore you, and then we'll come back in 15 minutes, and those that want to get the software installed and get it to work for themselves can stick around and we'll help get stuff installed. But I want to get everybody out of here sort of in time for on time-ish. And as I said, we're always happy at our office hours to help you install stuff. It's probably the most annoying thing about computational science is the versions change all the time, and Macs and Windows computers change all the time. So getting stuff installed is no joke. So what I want to show you is RMarkdown. And what RMarkdown does is gives you a way to combine text, code, and output of the code. So if you go to the Etherpad document, I'd like to, and this is the document that was linked right off of the workshop page, so bits page, the Etherpad here. For the last bit on RMarkdown, we're going to use this file. And so this is a file, it's a .rmd file. And if you click on it, you'll see something that we'll come back to in a minute. This is a file that we want to put in a directory in our tutorial, under our project. So if you can see this file, now go up to File and Save Page As. And now you run into that problem that I told you about, where my web browser is very helpfully saying, well, I don't understand what RMD is as an extension, so I'm going to name it .txt. You don't want that. You want it to just be .rmd. So you can do this in a couple ways. You can go back to the Etherpad and you can do right-click or save as, save link as, or in this case, it actually works to just remove the .txt. I'm actually going to put mine in the tutorial papers directory, but you can put it in the data directory or wherever is convenient for you. You just, again, need to be able to find it. So if you put it in your data directory, remember that you put it in your data directory. Now, save it. Again, here, my web browser is saying, are you really sure you don't want this to be a .txt file? And I'm saying, yes, I'm sure. If it's a .txt file, it's not a big deal. You can rename it. But and now I'm going to open this in RStudio. So go over to RStudio, open file, and in my case, it's in results or papers, example.rmd. Okay, so everybody who gets to this point, please put a yellow sticky on your laptop. How do I hear? Why can't I do it? Desperate search for a sticky.
Sorry.
.txt file. I just added the extra extension. So I just yeah, I would, so I would just open the browser. Just, actually, I would just go to that. And then just single click on it. So that, oh, there it is. Just on our on the ebook. There must have been a but it isn't open up in our so that's a recognize it's a markdown file. Here we have to change so it's weird. It's weird. Can we go and rename changes that?
I'm good.
Just right click. Yeah, and then let's, yeah. Let's try this. Yeah. Can we try something else? Okay. So let's just copy it. Oh, just control A. And then open that. Yeah, one of them all. It's a little text. Let me try search. Yeah, there it is. Okay, let's see that.
Biggest deal is linking what you're doing with the actual syntax.
Okay, I think I'll move forward a little bit. So, okay, so looking at this file, programmers do everything in two stages. There's all of the code that specifies the output, and then there's like something you have to do to execute that code to produce the output. RMarkdown is basically the same thing. It's no exception. Basically what we're doing is we specify a combination of text and code. And here the text is sort of just this stuff, and it's straight up text with some what's called markup in it. And markdown is a play on the word markup, because programmers also love that kind of joke. And so what you'll see is that this star star knit star star, the stars around it tell RMarkdown to bold this in the final product. The back quotes here tell RMarkdown to render this as in a computer font. And then here, this text says, okay, what we're going to do is in the R language, run these two commands. These two commands should be familiar. This says load the tidyverse in and load the tidyverse library packages, and then read in Gapminder. And there's more in this document. You scroll down, there's a bunch of stuff. And what I'm going to do is try to run this. And to run it, what you actually do is called knit. There's this handy button up top that calls knit. In my case, I've already installed the packages. If you click on knit, it's going to ask you to install some packages. So that's when things might not work for you, in which case we're happy to help in 10 minutes or so. So click on knit, and what knit does is it goes through and it runs all of the, it goes through and it runs all of those examples, and it produces this nicely formatted document at the end. And this document has the text that I put in. It has a markup. You can see how knit here is bolded. Read.csv is in computer font. It has the R commands. It has the output of the R commands, and then the warnings and so on, all in there. So what it's doing is it's literally taking the text, putting it in there, and then interspersing the text with what it ran and what the output of it running was. And if you scroll down, the coolest thing ever is that the plots show up right in the document. So now you have not just whatever manipulations you use to load the data and to query the data, but also the actual plotting output of the data directly in this nicely formatted document. And so rather than giving your collaborator or your advisor the R code that you use to generate something together with the comments on what you were doing, you can actually produce nicely formatted plots containing discussions of what the data means interspersed between the plots. And this is dangerously close to what an actual paper would look like. And there are, in fact, ways to convert this into a paper that's ready for submission to a journal. And so you can literally go for an analysis that's got a lot of computational work, and you can literally go from an RMarkdown file all the way to a final formatted paper that can be submitted for review directly. And for some of us, that is that is one of the goals of sort of the next round of for next generation publishing, so to speak, which is that when I review this paper, if I were to review this paper, it could contain a link to the raw data and the R code that was used to generate the results in the paper, and I can replicate their analysis exactly. I can repeat their analysis exactly by downloading it and running and clicking run, and then getting those results. Yeah.
So this will link your raw data into this file?
So no. So what this does is it's essentially a shiny view of the plots. To link the raw data, you would need to actually provide someone with the whole R project directory, so that whole tutorial directory. But that tutorial directory is a really great question. That tutorial directory does have everything. Think about what we're doing here, where we have a CSV file in that project directory, we have the RMarkdown file, we have the scripts that we use to play with the data. It's all in that one directory, and you can zip that up and actually submit it as supplemental data. Or if you're using version control, there are ways to point people at a website that would host that for you, and then they could actually, as you work with collaborators or updated things, that you go there. So that's what we do in our lab.
So can you save yourself a copy, everything,
Yes.
say, one place?
Yep.
So you can go there.
So you can save this all and put it in one public location. It's a place like GitHub or Bitbucket.
Yes.
Any questions at this point? How many, just quick show of hands, how many of you have managed to run the knit command and install everything successfully? Half to 2/3. Okay. It's a couple of packages that need to be installed. So, okay. So those of you that want to play with this, get rid of this window, come back to the RMarkdown document and change this plot command. So I'm going to get rid of the theme EW. Actually, I'm going to get rid of the log scaling on mine, and then try rerunning. And what I'm trying to do is show you that those plots really are updated. When you click on knit, you get the actual latest version of running that code. So you can put whatever plot you want in here. And actually, maybe I'll just add a, maybe I'll just make it a violin plot. So I really like violin plots. So I change the code in there to whatever I want. I can copy and paste it from my script. I can fiddle with it, and I can click on knit. Let's see what happens. Ah, there's a bug. Excellent. So there's an error in my code. Nope. Hey, that's a really good guess. Aesthetics. This actually needs to be enclosed in AES. So it's still running. I think the main point here is this is still running all the same things that we were running before. It's now just embedding it in this other environment where you can get the text and the plots all in one go. Okay, so clearly I need to do some changes, make some changes to the plotting here. But you can see that it updated from the source code that I put in the Markdown. If you want to learn more about Markdown, how would you do that? Google it, right? And you'll come to the, thank you, yes, right? You've learned the most important thing. Just use Google whenever you have a question. Yeah. So I think, so I'm happy to, yes, please go ahead.
So when we were talking about color versus fill and things like that, can we use question mark ggplot to find out what all the
Yes. Yeah. So in the so the question was in RStudio, where is it? Console. You could run all of the help stuff as you normally would in the R console with question marks and stuff. So basically, RStudio really integrates well with the rest of the R ecosystem. Isn't that? I mean, that's what they sell. So nothing that you are used to in the R console should be worse in RStudio. It should always give you sort of better stuff. Any questions at this point?
How would you do the project management once you have different plots and different analysis from the same data?
Right. So the question was, suppose I have a project that's gotten big, as they tend to. I maybe have more than one data set. I maybe have, it's all part one project, but I have more than one data set. I have maybe a dozen plots or 100 plots or whatever. How would I organize that? How would I manage that? And it really depends on what the goal is. If the goal is to do the same analysis to 100 different data sets, then I might have one script that does the analysis and another thing that calls that analysis 100 times. If the object is to do a meta-analysis across 100 data sets, then I would have one script that loads all 100 data sets and does that meta-analysis and outputs the graph for that. So really, there's no one right way to do this. There's just, is it automated enough that you can easily change it and update it as things come along? Yeah, does that make?
So your goal is to have data, then they need papers.
Yeah.
Right, and then if you have different data, you do another project.
Right. So if you have a different data that belongs to a different project, yeah. And sometimes it can get confusing, right? So suppose you have 3 different RNA-seq projects. They're all using the same underlying scripts. You can do the OK thing, which is get working on one and then copy those scripts. The problem then is if you fix a bug in one, you have to remember to update the other scripts. The way that people deal with this is they build their own libraries for doing this. So they have an RNA-seq analysis library that's specific to the lab, and then they share that between projects, and that way they update that once. And they just have to remember to reinstall it for updated there. So a variety of ways of doing that. One of the things that we can offer you at our office hours is we've made all the mistakes over the last 25 years. I've made all the mistakes, multiple times often. And I'm happy to sit down with you and talk through, this is the kind of data we're expecting. where am I going to store the raw data? Where am I going to store the results? How am I going to organize the project? And I won't necessarily be able to tell you, but I can tell you what the trade-offs are sometimes. Because, as I said, I've made all those mistakes. Most of the people that I know have settled on a workflow kind of like the one I described. They have a project that's sort of per scientific project. And then if they have code that's shared between those projects, they pull that out and put that in a common place. They don't mess up and accidentally fix a bug for one project and not for another. It gets worse, it gets harder when you have undergraduates. And when you have a larger lab, it gets hard because all of a sudden you have to coordinate between multiple people. And I think that that's where things like GitHub and shared code repositories and a lab ethos of caring about this, that's sort of one of the reasons we do training, is because we have new people coming into the lab and it's like, well, we gotta tell you how we do things so you can take advantage of it. So it gets complicated, but you can grow into it, I guess would be the other point. You don't need to immediately do all of this stuff in order to take advantage. You can do whatever you think works today and then just be on the lookout for the next thing that's causing you trouble and fix that. What you really want to do is avoid manual labor. You really want to avoid where you're taking one data set and you're taking 10 data sets and doing the same thing 10 times with a lot of typing involved, because then you're going to mess something up. And it's going to be inefficient when you need to change, like, oh, the reviewer asked me to plot this data in a completely different way, so I have to run the same plotting, I have to run different plotting commands for the same 10 data sets again. Once you do that 2 or 3 times, you know, taking a day out to like come by and shop with us might be a good investment of time, but it's up to you. So unless there are additional questions, no? Okay, I'll stick around for a little bit after this, but I just wanted to say I like to try and set expectations. You know, this isn't something that you can learn in a day or a week, but it's something you can get started using in a day or a week or a month. And the real trick is to keep on using it. Everybody I know is continuing to improve in their skill set. And the way they do that is by continuing to work on it rather than saying, well, I'm going to do it the bad way today, and then I'm going to learn to do it the good way, and I'm just going to do it the good way tomorrow. It doesn't work that way. That having been said, it's really not, I don't really know how to sell this, but our job is data analysis and data interpretation. So learning to do a better, more reliable, faster job of it counts as skill building and is something that you should think about investing a little bit of time. We're happy to serve as a resource for you in doing that as our other people on campus. One last comment is the skills that we're talking about here are really valued outside of academia as well. So if you ever decide not to stay in academia for the rest of your life, these skills are something that companies are actively looking for, and it's something that scientists are particularly good at compared to people that haven't gone through and gotten the critical thinking and data analysis side of things. So with that, I just want to say let's just thank all of the helpers, and we'll call it quits. All right, I'll turn off the recording now. It'll be available on the website, and I'll stick around for a bit in case you have questions or comments.